Good evening to one and all. Myself Gayatri Mode. I am here to explain the two quantitative techniques covered in our course. So, one measure optimization model and also one measure forecasting model. The measure optimization model, I'm going to introduce that. Like, I'm going to present a Python based supply chain optimization model. So that model implements multi-objective optimization, and I'm solving a facility location problem here, and we have a multiple facilities and demand points. So the main goal is to assign each demand point so that it should exactly have one facility in a way that can minimizes a weight, that is the combination of the distance and the cost. So here I used the type, which is Python optimization library, and I also the optimization is multi-objective that will balance both the cost and the distance by using the weights. So I used a sample data set with two facilities and the three demand points here, and this is the quick code for the optimization model. I'm going to explain you in the VS Studio here. So this is my optimization model with the example. So here I created the class called supply chain optimization class to make the optimization model clean and reusable and the modular. So in the constructor I pass the four inputs, which is cost, distance, facility and the demand points. So the cost is like of serving each demand that point from the each facility, and the distance is the distance between each facility and the demand point, and the facility is the and the demand points are the full list of each that will help the model flexible for any input of size. And here is the decision variables, like it is in the solve method we define binary decision variables, like here I mentioned here. So x of f of d is that equal to 1, which is facility f serves demand point d, and if not, like else 0. So the goal is to minimize the total score. This way the model can balance both the cost and the distance using the weights here. So here each demand point must be served by the exact one facility. So we add the constraints so to ensure only one facility that is assigned to each demand points. So after solving the model, we will print the optimal assignment, which is facility should serve which demand. So based on the lowest weight score, we get an output. So here we define by, as I told, binary decision variables that will represent whether a facility serves a demand point. The objective function is weighted, and each demand point must be assigned to exactly one facility. So this is the example, like a sample, and here I given the weight cost and the weight distance, which is 0.6 and the 0.4. Now quickly I am going to run this code. So the output which I got is the facility F1 serves demand point D1, and the facility F1 serves demand point D3, and F2 serves demand point of D2. So it calculates a combined score for each facility demand using the formula like cost into 0.6 plus 0.4 into the distance. This way it balances both the cost and the distance instead of picking just cheapest or the closest. So the main thing here is it is generic. We can pass any number of facilities and also any demand points, and the input dictionaries and the list are dynamically processed in this optimization model. So this demonstrates how multi-objective optimization helps to make efficient decisions in the supply chain problems. It extendable to real business scenarios also, like with the hundred of facilities and the constraints. And next thing which I'm showing you here is my forecasting model, which is simple exponential smoothing. So in this is especially used when the data has no strong trend or seasonality. So that example that will help the business plan, like for inventory, staffing, or the production needs efficiently. So here I use all the variables like parameters, which is alpha, that will control how quickly the model should react to changes. And like if alpha is close to 1, the model will be react very quickly to recent changes. If alpha is closer to 0, it moves slowly and react very less. So I'm gonna show you the code in the VS Studio here. This is my forecasting model code on the VS Studio. As I implemented this model from scratch in the Python, the class takes the alpha and the historical data list as input that will like calculates the forecast step by step without using any external libraries of forecasting. This keeps so simple, scalable. So here is the code which I created, the simple exponential smoothing class, and to keep the model reusable and the organized. And the constructors I passed the alpha, which is the smoothing factor. As I told, it should must be between 0 and the 1. So between 0 and 1, if alpha is too high, the forecast changes quickly. If it is too low, the forecast become very stable. So this is the main method called forecast. It takes the full demand series as an input. We first check if the list is empty, then set the first values as the initial forecast. And this is the formula for the SES which is applied, that is forecast equal to alpha into actual plus 1 minus alpha into forecast, which is previous forecast. It runs through each month's demand, updating the forecast of each time. In this main part of the code is I provided the 12 months of demand data, the alpha given the 0.5 here, and then I call the forecast method and it returns the predicted demand for the month 13th. So the output of this will be the forecast for the next month, which is like month 13th. By running this code, I am getting the output as a 183.33 here, which means like the final forecast which is printed. That means this is what a business would use to make, like for to make an inventory or the supply decisions. So the majorly what we learn from these two projects is from the optimization model, which is multi-objective, which I used. From that model, that will help to decide which facility should serve which customer, like by minimizing the both the cost and the distances. And also it finds the most balanced assignment using the weights, so we don't always pick the cheapest or the closest, but the best trade-off we can. And from the forecasting model, majorly we can learn like how to predict the future demand, like by giving more weight to the most recent values that make simple but very effective for steady data. But and also the alpha